Okay, now number 3. So we're still using the same formula here. So just the way of asking is a bit different. So this is given here. This is a geometry progression, and this is term n. So they want you to know or to find what is n. Okay, the number of term. So what, as usual, we have to find what is the r lah. The a is given. A is negative 25 over 3. To find r is similar like the difference. So difference arithmetic progression, you take the second minus the first. So for geometry progression, you take the second, divide by, because it's common ratio, right? So you divide with the first. So you can use calculator to do. Okay, make it a bit faster lah. Okay, so divide with negative, don't forget negative 25 over 3, so you will have negative 1 over 5. The a is negative 25 over 3. So this we are dealing with fraction here, so it looks a bit of hard. Okay, but it's not really that. Okay, so term n is given, so 1 over 9375, 9375. So using the formula ARN minus 1, okay, this is 19375. So the common ratio is 1 over 5, and the a is negative 25 over 3. So negative 1 over 5 and minus 1. So this is, okay, you write like this. Okay, so this is multiply, so you bring over, it become divide. So n minus 1, so you divide with, so 1 over 9375 divide with negative 25 over 3. So you will get negative 1 over 78125. A bit of a big number there. Still okay, no problem. Okay, so now we have to try to get the 78125 in terms of power 5. So because we see here, okay, I have this power with n minus 1. If we remember the law of indexes, okay, either I have the same base and then I compare the index, or I have the same index, compare the base. So from here, I might have to make it the same base. Okay, that means to say I have to make it same base. So what is 5 power 2 to get 7, 8, 1 to 5? Okay, so that means I try for 5 power 5, cannot get. 5 power 6, still not there. This is 15,000. That one is 5 power 7. Yes, just nice. So we have to try one by one lah. Normally it will not more than 10 lah. Okay, we just try, or if not, you will have to use log. Okay, straight away use log. So that means this is power 7. Okay, so we compare the index. So n minus 1 equals to 7, so n equals to 8. So that means term 8. This is term 8 to get 1000, and then 1 over 9000, sorry, 9375. So this is how we do. Okay, we see another example here. Okay, so given that the Sn, so now they give the Sn formula. Okay, Sn formula, they need you to find Tn for the GP. So this is very important word. Yeah, the GP means that we only can use the geometry progression formula. Okay, so hence determine the A and the R, and then of the GP. So now they give you Sn. So by understand the Sn means the sum of term. Okay, the sum of term until the n term. All right, so when we have sum of term, so how to find Tn? Okay, so logic, you have to think a bit more. Okay, think a bit more. So for example, if I have a number, yeah, 7, 8, 9, 10. Okay, sequence. Okay, we try use arithmetic. Okay, it's the same concept. Okay, so another, if I add S2, yeah, okay, this is arithmetic because plus 1. So if I S2 means I take 7 plus 8, right? So 15. If I have S3, will have 7 plus 8 plus 9, which is 24. Okay, so to know what is the term to first, second, third, yeah, I want to know what is the second term. Okay, I will take S3 minus S2, because S3 is 24, I minus 15, I get 9. You see, so logic says, okay, it's logic. Okay, if I have a series of number, I add up. Okay, I add up. If I take the 3, add up 3, I minus the one that before, means I will get the term on that number. Okay, for instance, this is the example that I have. Okay, S3 I add 3 number, S2 I add 2 number. So to know the third what is the third term, alright, I just take the S3 minus S2. So similarly, I can derive a formula saying that if I want to find Tn, I can actually Tn is 2, right? So I have n plus 1 minus Sn. See, I will get my n. So since they give you Sn equals to this, so to get the Tn, I will just take Sn plus 1. I mean, sorry, I just substitute on it 2. If n is n, okay, then n plus 1, you just take 2, n plus 1 plus 5, okay, minus with Sn, 2n plus 5. Okay, so after that, 2n plus 2 plus 5, open bracket. Okay, so this one is minus, so I have to become minus. Okay, so now 2n minus 2n, so Sn equals to no more n. Okay, so 2n minus 2n equals to 0, so 2 plus 5, 7 equals to 2. Term n is 2. Okay, cannot be. What's the problem there? So we try Sn. I copied the question wrongly. Okay, so the question is 2n squared plus 5n. Okay, something is wrong there. We cannot get 3n equals to 2. Okay, so that means I have to, okay, this one. Okay, so put it. Okay, put it. Okay, put it together with so 2n squared, so n plus 1 here. Okay, then minus with Sn, so 2n squared. This question I create. Okay, so something is wrong there, so never mind. So 2n squared means we have to expand first. Okay, expand first, then only simplify. Okay, expand first, then only simplify. So after you expand, you will get 2n squared. So that means you multiply it in 2n squared plus 2 plus 4n plus 5n plus 5. Okay, then minus 2n squared plus minus 5n. Okay, minus 5n. Okay, now you will have, okay, 2n squared minus 2n, 2 plus 2 equals to Tn equals to 2 plus with 4n plus 5. Okay, so you have 7 plus 4n. So this is Tn. That means term n will be 7. Okay, to know what is A, you just put T1. Okay, T1 is A lah. Okay, so A is T1. So T1 equals to 7 plus 4. So 11. Okay, So to get T2, okay, 7 plus, okay, 7 plus T2, 4, 8, so 15. Okay, so your common R will be 15 over 11. Okay, so this question I just simply created, so this I have to have square there. Okay, I miss out the square. Okay, so now to fill in the blank and square just to confirm is correct. Okay, plus 1 2n, okay, plus 1 plus 5n plus 1 plus 5, okay, minus 2n square minus 5n. Okay, so I will have 2 2 4n, so 2, okay, there's no mistake there, so this is R, so I get my A and my R. Okay, so I get my A and the R. Oh, sorry, so blue. Okay, so A is 11. Okay, A is 11 and R is 15. Term 2 divide by term 1. Okay, so actually you can do the progression. So and you will find that this is a geometry progression. Okay, number 5. So before we proceed, example 5, okay, we will see Sn. Yeah, this is the one. Okay, so Sn formula. Okay, so Sn formula that you can have here, that I already show here, is actually the meaning of Sn. The meaning of Sn is the summation of the progression. Okay, so to find the sum of S10, okay, to find S10, so you just use the formula there. So what is the R first? So R is 5 over 1. Okay, that means you have to get your R. R is second term divided by 1. Okay, actually 25 divided by 5 is also 5. So the formula that you have, okay, for Sn, okay, that means A, okay, 1 minus Rn divided by A1 minus R. Okay, if you see this formula, okay, A is 1, okay, because they want the summation, so you just put the summation. Okay, so then 1 minus 5 power 10, okay, then 1 minus 5. So just put into order. So you have 5 power 10, 1 minus 5 power 10 divide by 4, negative 4. Okay, if I put in the negative up, is 5 power 10 minus 1 over 4. Okay, so you have to do that lah. Okay, 5 power 10 minus 1 equals to 9, 7, 6, 5, 6, 2, 5 over 4. If I add up, S10. Okay, now find the value of n, okay, when Sn equals to 3906. Okay, so 3906. So okay, now there is a one thing here. Yeah, the formula given is this one. So if you see, okay, the formula given is this one. Actually there is something we can adjust. Okay, adjust. So that is what we can say here. If the R value, okay, R is more than 0, okay, and more than 1, okay, more than 1, like 5, 6, okay, actually this formula is for, you can switch. Okay, it's more than 1, you can switch the formula to A Rn minus 1, so that you will not get, I mean, because we want to use log after this. Okay, so you can do this. Okay, you can switch the Rn and the 1, okay, here. Okay, the reason is here actually. Okay, I can actually switch because of this. Okay, this one you see I already switched all the negative side and the positive sides, so I remain here. So this formula, okay, if R is more than 1, okay, then I will use this formula. Okay, this is less than, okay, r less than 1, okay, modulus 1 being positive negative, okay. So this a is 1, so r and I do not know, okay, r, okay, r I know, not, yes, I know r is 5, okay, 5, okay, then 3906, okay, so 4 times 3906 by 4, okay, plus 1, so 5n, no need log also can, 159,625, so 15625, just we put into power 5, okay, power 6. We have done this just now, okay, power 6, okay, 5 power n, so n equals to 6. I hope you can understand. Here I switch this one. I just want you to see that there are different formula I can use for different, it's the same formula, okay, I can use it when I have different how to say, different r, okay, but anyhow you will get the same answer, okay, you will get the same answer. Later we try one more, okay, where you have the r is 0 point something, okay, so this one means if the r is 0 point something, okay, then we will use this, okay, but if your r is more than 1, like 1.1, 1.2 or 2.3 and so on, 5, okay, then we will use this formula, okay. So if your r is 0 point something, we use this formula, okay. This is just some adjustment lah, but if you still want to use one of it, okay, for all the r still okay, no problem, okay, no problem, because in your books it's given, so I just need you to know, okay. So the r, when the r is less than 1, okay. Okay, next we will see, yes, sum of infinity. So sum of infinity is a new thing for you, so we have to prove it. I take it from your book, so your book we have proof, okay, we have proof that the r, okay, when it get bigger and bigger, all right, it will go near to 0, okay, near to 1, okay. So when we have this near to 0, a bigger number, so this one will become 0, okay. So it's very easy to prove actually. In your book you have to go on, okay, like Rn, then n equals to 100, this is 200, 100, 200. It's very easy, just use, let's say r is 0.5, if you power 10, you see it's near to 0, power negative 0.4. If I have power 1000, okay, if yes, it will show you 0 there. That means if I have r, a very big number, and the ratio must be less than 1, yeah, so this is the 1, okay, must be less than 1. This sum infinity only apply to a geometry progression when the r is less than 1. If the r is like 5 or 7, cannot, okay, that one we cannot do, okay, we cannot do sum infinity. All right, sum infinity is only for r less than 1, okay. So sum infinity, so we add on there to your thing, okay. So this is only for the r less than 1, okay, r less than 1, that means 0 something, 0 point something, okay. Positive negative is still okay as long as less than 1, okay. Less than modulus 1, okay. Modulus means positive negative, as long as negative less than 1, okay. Now 0 point something. Alright, so we can see here sum infinity, the function or the use of it is to get decimal, just like what you have before this. We can also do the rationing part, okay, in chapter 4, okay, chapter 4 we also can find the decimal, okay, the decimal into the fraction using the fraction, using the equation, okay. So that is what we have in chapter 4, okay. So now in chapter 5, okay, we can also express. So when they want you to use geometry progression, the infinity sum, okay, they will just write inside the question. If they don't write here, you can use any method, any method that you can remember lah. So hence express in the simplest fraction. So what we can say here, okay, since this is an okay, it's a 0.563 is repeating, okay, so it's almost similar to what you have, okay, so it's 0.063 plus with 0.63, so 1 2 3, so 1 3 3, okay, 30, then plus with 0.00063 and so on. So it means that you can see that here, okay, here is actually a geometry progression, okay, geometry progression. When you add, you can get this one, okay. So where the geometry progression A is 0.063, the R is 0.00063 divided by 0.063, you will get 0.01. Okay, so this one will fulfill the condition, okay, where R is less than 1, okay, less than 1, you can use that sum infinity. So as infinity says that A divided by 1 over R, so A is not 0.5, yeah, okay, A is this part is geometry progression, so 0.063, 1 minus 0.01, just use calculator, no worry, 1 minus answer, 1 minus 0.01, then you get 0.063 divided by answer, okay, 7.7 over 110, okay, so that means you can get this. Just press the fraction button. So that means to write 0.56363 in fraction, it equals to 0.5 plus with 7.110. This one is 5 over 10, 7.110. We have learned this. 0.5 is 1 over 2 or 5 over 10. 5 over 10 is easier for you to, I mean faster. Sometimes it's not 0.5, sometimes it's 0.7 lah, and so on. Okay, so it's easy. Just make the denominator as 10. Okay, 5 over 10 plus with 7.110. So the fraction that you will get is 31 over 55. So this is your answer lah. So sum infinity, if they want you to use, they will be very straightforward. They will say, find the sum infinity of the certain number. Okay, so that is all about chapter 5.2. Okay, 5.2. Sorry, a bit of rushing here. Okay, so you can do skill practice 5.5 to 5.9. Okay, and then intensive practice 5.2. Okay, so happy holiday to you. Okay, I see you again.